Hello, let's continue the Python exercise for the Hyoung-Goo model. So we basically calibrated one period model. And here the code is a bit messy. So let's use Python class. Let's use Python class to make this code prettier. So for this function, let's change the name of this function for temp. Okay. And then here, let's call it temp. And then temp. Let me check. Okay, everything looks fine. So here we say M0. And then to use class, okay, to use class, let's let's find the name of the class. Let's call the name of the class as Ho. So new code, so class Ho, okay. And then we first define now init, and then we plug, okay, sorry, okay, here we list up the variables we are interested in, the basic input variables. Of course, the first one should be self, and the second one is R0 and DT, and then we have for volatility and A2, price of bond we want to match, right? And then let's simply call two reduce names. So self R0 equal R0. Usually I use the same name. So and then self dt equals dt and self 4 equals 4. And then self A2 equals A2. Okay. A2. And then now we wanna define the function here, basically the function that return the difference between the theoretical value and then theoretical value and observed value. So let's call the name as Li1 because it's one period model. And then here, of course, the input is self dot m, right? Self dot m, self and m. Okay, so let's go to the beginning and let's reset everything. Okay, reset f, that this clears all the previous memory. And then let's run all. Okay, now here m, so pass. Okay, let me see. Okay, good, no error until now. And then basically we implement the same one, but now it is hard coded with numbers and we don't have to do that. We can be more general. So instead of this one, we can call those ones. Right? Self. And then we can define interest rate over here, and then we can call this one. Okay, so actually it is not, and then actually it should be the other way around. So to simplify, R0 is self dot R0. Basically, we are calling the number, okay, the previous information, and dt equals self dt, and then for self for, and then a2 is self a2. Now next, then we don't have to put self over here because it's too messy. So we can use clean notation. And then next thing is we have to calculate bond price. Bond price when interest rate go up and go down. Copy. Actually, we copy this one. Okay, copy this one over here. And then N0 looks like this. Okay, so basically we calculated bond prices. We calculate how bond price, 6 months bond price change when interest rate goes up in 3 months and then go down in 3 months, right? And then now we can calculate return. Return, of course, the gap. Gap is basically between N0 minus A2, right? So this is gap. So we define the function. Okay, and then let's test whether our class is fine. So let's call bond one. Bond one equals now, well, it should be order should be looks like this. So bond one is, let's say, Ho, and then let's put this one. So of course R0 equals, we put it, R0 was this one. Okay, let's move this one. And let's move this one. And then A2 is the bond price. A2 is this one. So let's move this one again. Of course, we already defined it, but move it again. Okay. So R0 MTT4. Okay, we determined it. And then bond one is basically bond one is the instance. It is instance. So Ho, and then we use this yes, this initial guess. So let's delete it. We don't need it. So R0TT4A2, R0TT4A2. So I just determined the bond one, information for bond one, right? So of course, now given that bond one, now we can try this new function Li. So for here, we can bond one, and then we apply this function here now, Li1, and then this R0TT vor A2 are all now, this information is now all here, and then all we need to is we can put the initial guess, and then let's put initial guess over here. Initial gas is 0.02. And then we put M, right? And then we have exactly the same pricing error. And of course, we know what is the correct M0. And if we put M0, then of course it should be 0. And it is indeed 0. But let's put M for the timing. And then we will create function, right? Write down again, fsolve, and then bond1 dot re1, basically same. And then we put M, or instead of 0.02 initial value. Then we found initial value, and then optimal value, the value that optimizes this one, which makes the observed bond price and theoretical bond price same. So this one, then we have exactly the same one. So we solved it. So let's call this one M1. This M1 is the correct M. Okay, but this one, we can also include this one into our class. So into our class, let's define another name. So because we are full, let's call it M0, M0, right? And then we need this initial value. So self.m, and then we can simply return, okay, return of fsolve, right? Return fsolve, and then actually we don't actually did this one. Fsolve, and then self, and then re1, right? Basically, we are going to use the same one as this one, and then initial value, right? We put initial value, which is M. Oh, sorry, it is not point. It is the comma. So we read M and put initial value of the M. Then it minimizes, it finds the solution for M, and then we will return the just the value. So we are done. So let's try print bond1. Now we can basically solve this one directly, and then print M0. And then we can put the initial value of 0.02, 0.01 this time. And then, right, we have exactly the same number. Okay, so in this class, now we included the function or routine that find the minimal value, the optimal value of the M that matched the theoretical 6-month bond price and observed 6 months bond prices.